of all the chapters. Okay, wherever you have any questions, please immediately quickly raise a question. Okay, so is it okay if I'm going to start with the safety, or you want design first? No answers. Can I take it as yes for safety? Okay. Now, let's start with the importance of safety. The first topic is importance of safety. Why do we need safety, first of all, in the industry? See, basically, whenever you're answering the questions in terms of ESE, most of the time they're going to look at the safety from the perspective of the industrial safety. Okay, so they're going to ask you questions in terms of safety related to design, related to industry. Okay, this industry can comprise of construction, manufacturing, infrastructure, which can be roads, dams, etc. So all these things are going to be asked in the what is it called ESE questions. Now, when we're talking about the importance of safety. Okay, now when we're talking about the importance of safety, why do we need safety, first of all? Okay, in an industry, in a construction, etc., etc. So the first important point is implementing safety in the industry provides consistent. This is one thing that you have to keep in mind: consistent growth for the company or the industry. Okay. Second, it boosts the morale of workers. Okay, it provides comfort and confidence for workers. Last but not the least, it attracts visitors. Okay, now you might ask me, sir, what is the importance of visitors in an industry? See, whenever you want a new project, okay, or whenever you want what is it called? It can be a new project or it can be a new venture, anything. The sponsors or a new project that has to be assigned to the organization, etc., is done by some visiting authority. Okay, if it is not a safe working environment, it is not going to attract or it is not going to allow them to actually what is it called? Provide some acceptance for the projects. So this is the importance of safety in an organization. Okay. Next, let us go over some normal, very simple terminology that is used in the safety in terms of industry or construction. The first one is accident. What is an accident? Any unplanned event that can lead to loss of property or life. Okay, that is known as an accident. Okay, the next one is incident. What is an incident? Any unplanned event that leads to what is it called? That stops or that affects one of the set objectives. It can be anything. Okay, it need not cause loss of property or life, but anything that disturbs the set objective is known as incident. So you can also say that accident is a subset of incident. Okay, the next one is hazard. Now, when I'm explaining this hazard, I want to go for a new page. 1 minute. Sorry for the break. I just had to take some technical queries. Okay. Now, one of our friends have asked a question like, what is the difference between, or is the accident necessary to be considered to be a loss of life? No, anything that can, I mean, it can consider loss of life or loss of property or injuries. Anything is an accident. Okay. Now, loss of life, loss of property or injuries. Okay. Now, in comparison, in terms of accident and incident, okay, anything that affects. An example of accident is a car crash or an accident that a vehicle has hit some pole or anything is an accident. Okay. Now, what is an incident? Okay. Anything that affects the set objectives. Suppose you are traveling from what is it called? Suppose I mean that's what should not happen, but suppose we are going through a class. Suddenly there is a power cut off. That is an incident. Okay, did not cause any what is it called loss of life or property, but it affects our set objective to continue with the class. This is an incident. Okay, again, if I'm taking the same example, I said that incident is a superset of accident. That means accident is a subset of incident. So once there is a car crash or an accident, okay, if a constable is traveling, okay, a police constable is traveling on the same road and he wants to report this accident to his superiors, he will not say, sir, there has been an accident, because it gives a different communication that this person is involved in the accident. So he says, sir, there is an incident where there is a car crash. Okay, so something that is an accident in one perspective can lead to an incident in another perspective. So it can change. So accidents are subset of incidents. Am I clear so far? Okay. Now the next word is hazard. The presence of any material, environmental condition, or health condition, anything that can potentially lead to an accident is a hazard. Anything whose presence is going to cause or has got a potential or probability to cause an accident is a hazard. Now, these hazards can be divided into two types. The first one is engineering hazards that we regularly come across. Engineering hazards can be divided again into something that are within the control of engineers. Okay, something like Okay, a leakage in a gas plant, wet floor, okay, worn out brake wires, anything that has got the potential to cause an accident is the hazard. Now, within the control of engineers means need not be exactly engineers, but anyone, or if a human interaction can prevent that, that is something known as within the control of engineers. Okay, now again, in the engineering hazards, some things cannot be controlled by humans. Okay, something like any natural hazards, it can be earthquakes or etc. etc. Okay, so some natural ones which cannot be controlled by engineers. Okay, these cause something known as design constraints. These cannot be controlled by engineers. Okay, these cannot be controlled by engineers, and whenever the engineer is designing a particular structure or product or anything, he considers this as a part of the constraint. That means if this happens, how is he going to mitigate the problem or accident or anything? That is what is known as a natural hazard. Okay, these are the design constraints. Now the third one is societal constraints or socio-political disruption. It can be terrorism, factionism, or war, civil war, anything. This is known as socio-political disruption. Okay. Now these are some of the engineering hazards. Now technically, when we go into the industrial hazards, okay, this can be divided into physical ones. Okay, the presence of what is it called, vibration, okay, or noise, all these things that affect or can cause deterioration to human health, workers' health, or cause delay in the work, or can cause an accident. All these things are physical hazards. Okay, a wet floor, anything, all these come into the physical hazards. The next one is chemical hazards. If the workers are working in an environment that is directly or indirectly leading to certain chemical environment, okay, that means the air is contaminated or polluted, okay, the presence of any toxic substances in the air or the medium where they work, that comes into the chemical hazards. The third one is mechanical hazards. Okay, not just mechanical engineering. Mechanical hazard means it can be a situation where the material handling equipment can fail, okay, or it is not working properly, okay, or the crane is not working properly, okay, or machine hazards, or it can be some energy ones. What are energy hazards? It can be a short circuit or a various other thing that can potentially cause an accident. These are mechanical hazards. Now, the next one is ergonomical hazards. Wherever there is a human machine interaction, if a person is working or if the worker is working for a long period of time, okay, with human machine interaction, the ergonomical hazard can potentially damage the health of the person or the worker. So ergonomic or ergonomical hazard. Okay, the next one is biological hazard. Generally, we don't come across this one in the regular industry, but if you are dealing with a situation where there is a medical field or pharmaceutical field, a biological hazard is a situation where the person can come in contact with a pathogen or some virus or any other thing, any biological entity that is known as a biological hazard. Okay, the last one, very small and very important, fire and dust. Okay, this particular fire and dust hazard. Okay, I can put it into energy hazards, but I want to deal them differently because any industry has got this particular problem. What is it called? As a highlighted one, and it has to be addressed straightforward. So fire hazard, how they mitigate it or how they handle it. Okay, so these are all the different types of hazards that we come across in the industries. Okay, engineering hazards and the industrial hazards. Hope this particular topic or this subtopic is clear or this definition is clear. Okay, now I'm moving to the next one. Once the hazard has been identified, we need to analyze the hazard. We are engineers, so technically, whenever we identify something as a problem or a potential problem, we try to first understand the problem and resolve it. So, hazard analysis. Now, this particular hazard analysis can be dealt through a simple diagram or a simple understanding that is given in the material. Okay, how do we actually deal with the hazard analysis? First, perception of the hazard. Okay, the person should be able to understand or identify that there is a hazard. Next one is cognition of the hazard. So, the first one deals with a situation where the workers are able to identify that there is something that can cause an accident. The second one is they have to define the hazard. Okay, so let me take an example here. Okay, the workers are working, and there is a huge raw material that is stacked up one over the other at two huge heights. Okay, and the material handling equipment is not working properly. Somebody should be able to tell to the management that this particular thing is not working properly, and it can it has a potential danger of causing, or what is it called, making all the raw material fall. Okay, so that is the perception of the hazard. People should be able to perceive or understand the hazard. Second one, cognition of the hazard. They need to be able to define what is the problem. Okay, the actual potential accident could be very much different from what is the root cause problem. So perception means understanding that there is a potential accident. Cognition means defining the root cause of that particular problem. So once this cognition is done, the people should be able to make decision to prevent hazard. Okay, whether they can prevent it, they can mitigate it, or they have to deal with it in a different months. Okay, or isolate hazard. All these things are taken in terms of decision that is supposed to be dealt while dealing with hazard. Now, are they able to avoid it, or ability to avoid the hazard? It can be physical situation, it can be a management decision, it can be anything. All these things come under the ability to avoid the hazard. Try to prevent or completely avoid the particular hazardous situation. If you are unable to avoid it, okay, deal with other methodologies that we are going to discuss later. Okay, now if all these things are done, then we have got something known as a safe behavior. If all these things are not happening properly, then you cannot expect safe behavior, and it can lead to an accident. Okay, so this is what is the simple steps in terms of hazard analysis. Now, technically, this particular hazard analysis goes in a very simple preliminary examination. Okay, and after the preliminary examination in terms of the perception or identifying the hazard, they go into a detailed analysis. Preliminary examination means the worker should be able to complain, okay, in terms of the perception and cognition. But the detailed analysis will help in terms of cognition as well as decision. Now, detailed analysis can use tools like FMEA, failure mode effects analysis, okay, or fault tree analysis. Okay, we can discuss this if we have time. What is the failure mode effects analysis or fault tree analysis? Okay, this is what is hazard analysis. Now, next. the last step is hazard control. How do we approach after identifying the particular hazard and after analyzing it? How do we approach towards the control of the particular hazard? The first most effective one is to eliminate the hazard. Okay, now after eliminating, or if the elimination is not possible, substitute the current situation with another little bit safer one. Okay, substitute the hazard with or hazardous situation with a less hazardous situation or less hazardous material. Okay, now even if the substitution is not possible, then try to isolate the hazard. Okay, so that there is a particular what is called as a hazard is happening in a very safe environment. Fourth, provide some engineering controls. This can happen in two ways. Okay, engineering controls also talk about the isolation of the hazard, where they provide a barrier between the person who's coming in contact with the hazardous situation, okay, and the hazardous material. Or the second one is controlling the parameters in such a way that it is safe for the workers while they are working for a specific duration of time, and they can recover early stage. Recover it daily. This is what is engineering controls talk about. Last one is use of administrative tools, or we can even simply say it as providing personal protective equipment. Either administrative tools talk about the process. Okay, certain safe procedures that have to be dealt with so that they can actually control or mitigate or eliminate the hazard. Okay, even if you're dealing in a hazardous situation, if you're actually following the process, okay, the hazard or the accident will not happen. This is what is one of the administrative tools. Or by default, certain industries provide personal protective equipment so that they can control the hazard. Okay, this is what is types of hazard. Okay, then hazard analysis and hazard control. Our next trend is the next topic that we are going to talk about is risk. Now, this particular risk again can be divided into engineering risks and again into industrial risks. Engineering risks talk about situations where whether when you're designing a particular product or building a particular product, or getting the things done, how this particular thing is about to happen. Okay, I'm going to come to the situation of explaining the difference between risk and hazard. Okay, first let me explain the types of risks. First of all, okay, engineering risks. Suppose if you're considering certain materials while developing a particular product, this particular materials or certain assumptions that we do while designing a particular product or building a particular product, certain assumptions during the design or developing of a product which are safe while designing, however proven unsafe at a different point of time. Okay, something like initially usage of chlorofluorocarbons was considered to be safe for refrigeration. Later it was proven unsafe. Okay, or you can also see that initial some of the petrol bunks say they are unleaded petrol. Okay, so initially at the very initial stages they used to provide lead in petrol to minimize the knocking phenomena in vehicles. Now after that they found out that the lead during combustion becomes lead oxide, which when inhaled can cause cancer. So they have removed the lead from the petrol and they're controlling it in a different way. So these assumptions that are proven safe at one point of time, however proven unsafe at a very different point of time, is an engineering risk. The next one is abnormal usage of the product. Okay, you define a particular crane that is being developed or built, to lift somewhere around 50 tons, but the current usage requires or demands 60 tons to be lifted. Now there is a time constraint or something. The contractor thinks that it is 50 tons, so technically let us try with the 60 tons. Okay, that is what is an abnormal usage. Okay, what happens next is not of our discussion right now because it completely changes the topic. But abnormal usage means something like that. Or a very common example is a bike generally is defined for two riders or two people to sit on, and we generally see 3 to 4 people sitting on the bike. That is abnormal usage of the product. Okay, next one is some design errors. Lack of information, lack of knowledge can lead to certain design errors. All these are engineering risks. Okay, first let us understand, as our friend has asked, what is risk. Okay, then we'll jump into the industrial discussion or industrial risks. Okay, now because of the presence of hazard, there is a probability of an accident. That particular phenomena is known as risk. Okay, because of certain presence of certain substances or exposure to certain conditions. Okay, our set objectives are not met or can lead to an accident or various other things. All these things are considered as risk. Okay, any event that that deviates from the set objectives, is risk. The presence of hazard causes this particular accident or deviation from the set objectives. That is what is treated as risk. So because of the presence of hazards, we identify that there is a risk of something not happening or not meeting our objectives. Okay, now this particular risk is generally dealt with the presence of hazards in terms of frequency of occurrence, magnitude of damage, or probability of occurrence. All these three factors are considered while defining risk or calculating risk. Now let us get back to the topic, industrial risk. In terms of industrial risk, you might have heard about this name. One is labor risk, liability risk, technical risk, natural disaster risk, and social or political risk. These are industrial risks. Very simple one. If you are dealing with this risk in terms of a management perspective, the workforce who can actually cause a various problems or presence of certain issues, all these things are treated as a labor risk. So if the workforce are causing some kind of a strike or various other things, and a kind of disturbing environment while working, all these things are treated as labor risk. The second one is liability risk. Any potential liability, in terms of usage or warranty or various other things are all civil or judicial things. All these things concerned with the industry are the liability risk. Technical risk, you can treat them as engineering risks. The next one is natural disaster risk. Whenever you are raising a particular industry, we always check about the potential cause of natural disaster in that particular region. It can be a flood, it can be an earthquake, or it can be a volcano eruption, etc. All these things are concerned in the natural disaster risk. Now, social or political risk is something the involvement of political or social activities in this particular problem. So these are all the types of risk. Now, let us deal or let us discuss this particular risk in product life cycle. Or in short, I'm going to discuss the objectives that the designers have to take care during the product life cycle in terms of this. So the overall product life cycle, I'm dividing it into 3 halves. The first one is conceptual design stage plus embodiment design. I hope you guys remember you guys completely know what is the conceptual design stage and embodiment design stage in a design life cycle. Okay, embodiment and detail also. Okay, this is the product life cycle up to conceptual design stage, embodiment design stage, and detail design stage. This is phase 1. Okay. The next one is manufacturing or construction plus operations and maintenance. These are the risks involved during the construction, operations, and maintenance of the product. This is phase 2 in the product life cycle. Now, after this particular usage, operations, and maintenance, the product is disposed into the environment. So, disposal scenario in terms of or the phase 3 of the product life cycle. Okay. So, what are the objectives that the designer have to take care in terms of risk during the overall product life cycle? So, the first one is conceptual design stage. This is the application of all the topics or materials that is there in order. Application of the things or the definitions that are happening that is provided in the material. I'm not talking something out of this particular scope of book. What I'm sharing here in terms of revision is how can they be applied into the real world. Okay, fine. So whatever is provided in the material is the base study material. Okay, that helps you understand what is happening around. This is the application part. Okay, now the first one is conceptual embodiment of detailed design stage. During this particular type of design, the engineers need to be provided what are the various working conditions of the product. Okay, they need to be provided with the information of or making decisions in terms of usage of the product. Okay, the materials that are to be used. Okay, the life cycle of the product. All these things are considered during the conceptual embodiment or detailed design stage. Okay, these include contributors to accidents or damage. This information has to be considered while designing. Okay, these are the objectives first. Second, whenever you're designing a particular product, ensure that this particular design is for normal working condition as well as an emergency working conditions. How do you use a particular product for regular work and in case of emergency? Let us take a very simple example of a lift. Okay, now elevator or lift, whenever you're using a regular working condition, it has to be designed in such a way that it needs to carry only limited amount of people or limited number of people in the particular lift while it is normally functional. Now, emergency situation is a situation where there is a sudden power cut off. So how should it behave so that it does not cause any damage? So typically you might have observed that many lifts are programmed in such a way that the moment there is a power cut off, it automatically goes to the ground floor and opens itself. It does not function after that. If there is a power cut off, immediately goes to the ground floor and it opens. So that if there are any people who are stuck in the lift, they're immediately allowed to go out. This is what is designed for normal and emergency conditions for a particular product. I'm just giving an example here. Similarly, for every product or every structure that you plan, you consider the design or risk during this condition for normal working conditions as well as emergency working conditions. The third one is provide proper info about manufacturing or to the manufacturing and usage conditions to the users or to the manufacturing people. So while transferring this particular product to the next phase, you have to provide all the necessary info of what are the usage conditions of this particular product or during manufacturing, how they have to proceed in terms of manufacturing. This is what is the risk mitigation that we deal with or objectives that the designer have to deal with while considering the risk in a product life cycle. The next one is manufacturing or whenever you're developing a particular product or constructing a particular product. Okay, the operations and maintenance. It's just about providing certain info. The same thing copies here, providing info about how the product should be handled. It can be during manufacturing or construction, or it can be for the user who's using the product. This is something that has to be dealt here in terms of manufacturing as well as maintenance or usage of the particular product. Second, whenever you are maintaining a particular product, okay, let us say that you're using a particular bike, okay, or a vehicle or a car, etc., etc. Whenever you're using that particular product, there is always a wear and tear in that particular product. Now, you have to provide, or you have to think about providing, or your objective is to provide certain maintenance allowable or decision making during maintenance. You might ask yourself, what is this decision making during maintenance? Whenever you give your vehicle for maintenance or service to the showroom guys or to mechanic, okay, or the maintenance guy, the first thing that he does is, okay, study the particular product, understand the wear and tear of various components of the particular product, and be able to decide that before the next maintenance, will the product fail or not? If there is a potential chance of failure, okay, he is going to report to you. But as when you're designing a particular product or when you're manufacturing a particular product, you have to provide proper means of studying the particular product. Okay, this is what is objective for the maintenance of the particular product. Now, the last risks that you have to deal or objectives towards risks during the disposal of the product. First, are you providing proper mechanism? Okay, or a process for the disposal of the product. Okay, second, are you considering the materials that are safe for the environment? Okay, so this is how we deal with the risk in the product life cycle. First, we try to identify the contributors for the risk in terms of design, contributors to the accident, and try to mitigate them. Second, whenever we are designing a particular product, we ensure that there is a risk that is, identify the risk for the normal working conditions and the emergency working conditions. Okay, and provide proper information for the user and the manufacturing guys or developing guys, construction guys, so that whenever they're building the particular product, they don't have any issues providing further. Okay, now when you are actually manufacturing or what is it called, operating, using the particular product or providing the particular product for maintenance, you have to ensure that, okay, this particular usage info has to be provided for the users of how to use the particular product, okay, or how to manufacture the particular product. The next one is proper provisions have to be provided in terms of maintenance of the product. Okay. Now disposal phase, proper mechanism in terms of process of the disposal of the product, and take care in terms of whether this particular product is what is it called safe for the environment. This is what is risk. Okay. Now the next topic is ergonomics or human factors. Simply said, okay, this is these are it can be ergonomics or human factors are related with considering the human machine environment. Okay, so the presence of this particular ergonomics can help the user in terms of providing comfort while working. Okay, minimizing the accidents while using the particular product. Okay, and on an overall, what is it called, minimizing the damage, or on a long vision, minimizing the accidents or health problems related to this particular product. Okay. Now the simple question is, am I going fast or slow? I just need a quick answer, yes or no. Either fast or slow. Guys, anybody alive? Can you just give me an answer, yes or no? Okay. I'm going slow. Okay. Slow and okay, fine. Let us pick up some speed. Okay. Now, ergonomics is related with the human-machine interaction so that it can provide comfort for the worker. It can provide a safe working environment for the worker, providing the what is it called, or avoiding the musculoskeletal disorders. Okay. And it should minimize accidents. Okay. These are the main objectives that you have to consider whenever you're answering questions in terms of ergonomics or human factors. They are not going to ask you in detail questions. Okay. Next, very simple, small topic is fire safety. Most of the material is given, or most of the things that you have to consider in terms of fire safety is given in the material. Okay, this is just an idea or perspective that you have to develop in terms of how any product or structure has to be developed, or whatever building is there. How do you, as an engineer, react to the fire safety situation? Okay, so you are not going to be asked in terms of engineering in terms of fire. Just the basic material that is provided here in terms of understanding how what is it called, fire behaves, or the science of fire. Okay, how this particular thing happens, or we call it as we call it as science of fire. Okay, now in an event of fire, what are the objectives or goals that have to be addressed in an event of fire? Okay, now the next one is, how do you provide fire safety? So first we need to understand how the fire behaves. So the first very important thing is fire triangle or fire tetrahedron. Okay, you know the fire triangle. Okay, the requirement of oxidizer, fuel, and an energy source that can actually trigger the particular event of combustion or fire. Okay, and how do we control in terms of that? Now that is the science of fire triangle. The next one is fire growth. Okay, now in order to understand the fire growth, we need to understand what are the types of fuels. Solids, fuels can be solid, liquid, and gases. Okay, how does the combustion happen? We need to also understand how this particular fuel burns or oxidizes itself for the fire, and after understanding this particular fuel combustion phenomena, then how the fire actually grows. Okay, and how it decays, or how it actually decreases. Okay, now fire triangle means these are the three aspects of the fire. Okay, or three vertices of the fire triangle. One is oxidizer, the second one is energy, and the third one is fuel. Okay, if you cut off one side of this particular thing, so in an event of fire, you need all the three: the supply of continuous provision of fuel, the supply or continuous provision of oxidizer. Oxidizer need not always be oxygen, even if there is a provision of any halogen, chlorine, fluorine, or anything, can also support combustion. So the provision of any oxidizer, and the third one is sufficient energy source to continue the combustion. These are the three things that are required for the fire to happen. Okay, so if there is just fuel and sufficient supply of oxygen, but there is no minimum amount of energy to trigger this particular what is it called, event of fire, then the fire will not happen. Okay, now any of the combination, you remove any of these three parts, any of this one, the fire will not happen. Or in an event, this same principle is used in terms of extinguishing fire. So if the fire is happening, okay, the fire extinguishers are designed or planned in such a way that they provide a cutoff of fuel, or they provide a cutoff of oxidizer, okay, or barricade the fire from provision of oxidizing substance, or they absorb all the energy from the fire, so there is no minimum energy to continue the combustion on the fire. So all these three things are used as an engineering controls to control or extinguish the fire in any event. Okay, so this is the fire triangle. Now technically, after going through the fire triangle, we need to understand how the fire grows, okay, or the fire growth. There is a simple curve that is given there, how the fire initially combusts. Okay, it goes something like this. In the initial stages, all the fire, what is called the fuel, absorbs the heat, okay, to get itself ready for the combustion. So all the energy that is released in the initial stages, as the time progresses, okay, the fire growth happens something like this. Okay, in the initial stages, all the fire or all this particular energy that is liberated from the fire or combustion of this particular trigger is going to be absorbed by the rest of the fuel to get ready for that for continuing the combustion. Okay, at that stage, if it grows to the sufficient amount, okay, where all the fuel absorbs the required amount of heat, okay, and are ready for combustion, this is where it reaches the top. And finally, after a certain period of time, there can be a situation where the supply of oxygen is minimized to the particular situation, or the supply of fuel is cut off, so it starts decaying. This is the fire growth curve. Okay, that is something in terms of fire growth. This is the science of fire. Now, technically, whenever we deal with the fire, okay, our important objective is fire safety. Okay, our goals are life protection and property protection. Okay, so we use certain tactics known as prevention. First step is prevention of the fire. Now, if the prevention fails and you go with the, if the fire event happens, then the next step is communication. Okay, now after this communication happens, then evacuation. Okay, call for the people to evacuate the particular building. Next, try to contain the fire. Okay, and if possible, extinguish the fire. This is going to be our simple objectives when dealing with the fire. Okay, in terms of fire safety. Now, any product that you're building or any construction that you're building, you have to ensure that these particular objectives are met goals are met, and this particular tactics are followed. Okay, the engineering principles can be in a way that it can first help in terms of the prevention of the fire. Okay, now if the prevention fails, then proper mechanism should be present in terms of alarming the people to evacuate the building. And whenever you're designing this particular structure, ensure that the evacuation of the building, the building is built in a way for ease of evacuation. Okay, now also provide various mechanisms to contain the fire so that it does not spread easily. Okay, the next one is extinguish the fire either with what is it called external help or provision of fire safety materials within the structure. You can do this. This is all is fire safety. Now, the next one is just understanding the industrial safety as it is. Okay, as a just default definition of understanding how the industrial safety should work. Okay, now first step in terms of industrial safety is provide proper training for the employees or the workers. Okay, this training is job description, history of the accidents. Okay, now next, the processes that have been developed to prevent the accidents. All these things should be a part of the training. Next one, okay, in terms of industrial safety is proper methodologies that the supervisors have to follow to prevent accidents from happening. That means the supervisors have to provide good housekeeping. Okay, what is housekeeping or good housekeeping? That means simply whenever a particular workforce is working in an industry or in the construction of a building, the supervisors have to ensure that, okay, at the end of the day, the workers keep all the raw materials at their supposed locations, all the tools at their supposed locations, and all the scrap has to be cleaned at the end of the day, every day. This helps. Okay, that helps. That means if a person is coming for the inspection at any point of time, he will not be subjected to any accidents. Or in the morning, if somebody comes in a hurry, he is not going to be subjected to accidents. Okay, also helps in terms of controlling this particular working behavior in terms of construction or manufacturing. So good housekeeping is one of the responsibilities of the supervisors. Second, supervisors should check the work permit of the workers. Are the workers healthy enough to carry the particular operations or the task for the particular day? Are they drunk? Okay, or various other things. All these things have to be taken care by the supervisors. Third, are the workers or the supervisors have to take care whether the workers are following the proper procedures or not. Okay, so procedures means safe procedures. Okay, these are the responsibilities of the supervisors. Next, whenever an industry, okay, in terms of industrial safety, safety is responsibility of everyone. This is a simple principle. Okay, nobody can escape from it. Also, the government of India has ensured that if an accident occurs, the onus of responsibility of the accident only goes to the management. Okay, the Indian government ensured that, okay, because if it is the management is one particular entity in an industry which can do or get anything done in terms of safety for the organization and the workers and the environment. So the person who's going to court holder, or the person who's going to be held responsible in case of accident is going to be the management people. Okay, various other things, something like provision of personal protective equipment. Okay, again, working what is it called? Safety procedures following or not. All these things are going to be the very simple things that you can go through the material, but these are some of the very important things that you have to keep in mind while answering the questions, or some just brief topics that you have to take care while dealing with this. Sorry. Okay, now the next topic is engineering design. Now, before I go into the engineering design, so far, any questions in terms of safety? Okay, I'll just take 10 minutes. If you have any questions, please type them out. I'm just going to answer. Okay. Some of the questions that are given here are, the first one is, sir, ergonomical hazard. See, whenever a particular person or worker is continuously working for more than 8 hours per day in a given particular posture, okay, first very important thing is we have to take care of the human-machine interaction or the human working interaction. That is known as ergonomics. Because if the particular worker continues to work in the same manner that is not ergonomic or that is not friendly with the human posture, then that can, on a prolonged basis, cause some health problems for the worker. Okay, a hazard is anything that has a potential cause of injury or what is it called, health or damage or an accident is a hazard. So if it causes in future health problems, even that is treated as a hazard. So ergonomics, if a particular person is not provided with ergonomic working environment, he cannot work on the particular job for a long period of time. He will face some problems. Okay, one of the very simple example in terms of ergonomical issues is going to be back pain, okay, or shoulder pain, or what is it called, weakness in legs or hands or various limbs because of the particular non-ergonomic working nature. Okay. 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 The next one is classes of fire. I'm going to discuss that. Now, another question that is being asked is work permit has any type or all types of work, like light work or height or work on hot area, etc., etc. See, work permit by definition means identifying whether the particular person is eligible to do the work on the given day. Okay, so the supervisor has to ensure that this particular worker who's coming into the organization or into the working area is able to carry out the tasks within the given orders, yes or no. That is what is the work permit. Okay, I'm not talking about work permit visas. This is a simple supervisor work permit to ensure that the worker is capable of doing the work. That means he should not be drunk. He should be capable of lifting the particular loads. That means he's healthy. Okay, he's not ill or sick. The next one is whether the physique of the particular person is capable of carrying out the respective tasks. That is what is going to be the responsibility of the supervisor. Now, another question that is being asked is how are the supervisors and good housekeeping linked? See, supervisors are the people who ensure that the working of the particular organization happens as per the expectations. Now, when the management has any problem, the first point of contact is not going to be the workforce. They are going to only catch hold of the supervisors to ensure that the work is happening as per the procedures. Now, the supervisors have to check the good housekeeping to be what is it called? A good housekeeping in terms of any working nature. That means if it can be an industry or it can be a construction or various other things. So let us take the example of a construction site. Every day, the supervisor has to check whether the workers have completely cleaned the working site or not at the end of the day. Okay, and all the tools are actually placed at their respective locations or not. Are there any sharp protrusions that are coming out, or if there are any sharp protrusions, that has to be properly either marked or it has to be properly binded or made sure that this particular sharp protruding object will not harm anyone. Okay, during the night or the next day when the person is coming into the work, that should not harm him. Okay, so that is the responsibility of the supervisors. Though it is done by the workers, the checking responsibility is done by the supervisors. Okay, now can we expect questions on rules or acts regarding safety? They're not going to ask in terms of various acts, but they're going to ask you questions in terms of a very logical answer. You can derive from that particular thing, that presence of that particular act, or from the definition itself, you'll be able to derive what are the things that have to be done with respect to that. Okay. Okay, one of you have asked the slides, you want to take a screenshot. See guys, this particular thing will be saved as a PDF and shared with you guys after that, after this particular class is over. So don't worry about that. Okay. Yeah, I just shared as PDFs. So the questions are over. Any more questions? Done. Okay. I think the questions are done so far. So let us start with engineering design. Or in short, general principles of design. Okay. My handwriting is not very good because I'm not used to this kind of tools before, so please bear with me. Now, general principles of design. The first thing that we are going to talk about is what is the definition of design. We can go through the notes or materials. So basically, design by definition means developing or devising a particular component or system or process that meets the need of the customer. Customer can be anyone. Okay, so customer is anyone who is directly or indirectly related to the product. Okay, so whenever you are designing or devising a particular product, system, or a process, any of these three things, okay, to meet the needs of the customer, it can be decreasing the cost, it can be called improving the efficiency, various other things. Okay, all these things come under design. Okay, now quickly let us discuss or understand what are the different types of design. This particular types can be divided into main types and auxiliary types. What are the main types? And adaptive design. Okay, this particular in adaptive design, you can understand it as the product is already there, and there is a particular adaptation of the product to meet the respective needs of the customer. Okay, that means let me put it as a very simple thing. The design of a particular crane is already fixed, but only thing is we have to vary it based on where the particular crane is being used. Okay, it can be used in a very swampy region, or it can be used in a very remote region, or it can require a various situations where the load has been increased. All these things come under adaptations. Okay, now the next one is redesign or developmental design. Now, this particular redesign or developmental design happens in two ways. The first one is we are trying to fix a particular error in the existing product or a design. Okay, now, or we are trying to update the existing design to meet the what is called market competition. This is what is a redesign or a developmental design. Now, the next one is original design or innovative design. This is a particular what is called an extreme situation where the designer builds the product right from scratch, understanding the needs of the customer, and this particular idea is also original and very new to the market. Okay, and it can sometimes be, or this is also known as an innovation, or it can sometimes be an invention. Okay, so I hope you understand the difference between innovation and invention. Now, the next one is auxiliary design types. Here, we have got some type of design known as selection design. The next one is aesthetic design or industrial design. Selection design means all the components that are actually required for the particular product are already there. All I'm doing is identifying the potential or identifying the right components from the catalogs of various suppliers or identifying the various components from the potential or capable vendors or suppliers. Okay. Now the next one is industrial design. Whenever you're designing a particular product, ensure that it meets the what is it called the eye or aesthetics of the particular customer, so that he can purchase it or he's attracted towards the product to purchase it. This particular thing is known as industrial design. Okay. Now, out of all these five, which one is the most? Which type of design requires the highest amount of experience? Okay, and skill of the designer? It's going to be original design. Okay, original design requires a huge amount of skill and experience while designing a particular product right from scratch. Okay, I hope you have understood the different types of design. Now, the next one, whenever you're designing a particular product, okay, you come across with various requirements for a particular product. Okay, these are known as 4 C's of design. Those are creativity, complexity, choice, compromise. So whenever the designer has to build a particular new product, okay, he has to be highly creative in nature to build the product, okay, by using various or tailoring various different fields of engineering, okay, to build the particular product that meets the need of the designer, meets the need of the customer. Okay, complexity means analyzing and resolving various parameters or variables while dealing with the product is something that is dealt in terms of complexity. Choice. At each and every situation, the designer has to make a choice, okay, or make decisions in terms of choosing what is the right, okay, suitable requirement or parameter for that particular thing. It can be material, it can be dimension, it can be size, it can be various variants. All these things, there has to be a continuous choice that the designer has to make based on the type of customer or the need of the particular part. Okay, the next one is compromise. While doing the designer always faces some kind of constraints. It can be time, it can be budget, it can be various other things that leads to certain compromise in certain parameters. All these things are the 4 C's of design. Okay, now very simple one. What are the skills required by the designer? What do you think are the minimum required skills for an engineer while doing a design of a particular product? He needs a knowledge skills, the core knowledge of engineering or the particular design of a product. All these things are the knowledge skills. The next one, not having the knowledge is, having the knowledge is not just sufficient. You should be able to communicate. This is the second skill that is required, communication. Okay. Now, not just having, it's more like communication situation where you have a particular idea and you should be able to present it properly. Okay, so the communication deals with presentation skills also. Okay, now, not just this particular design, this engineering also requires a proper documentation skills. Okay, so knowledge, communication, documentation are very important skills that are required by the designer. Okay, let us now understand, in short, a very quick understanding of what is a design overall process. Okay, now, you might have noticed that this particular design can be explained in 3 simple different ways. Okay, in all the materials or all the books that you go across, it is treated as, the first one is iterative approach. The second one is problem solving approach. The third one is product lifecycle approach. A common question that you might have asked is, that you might have got is, sir, are these 3 independent? No. Okay, within the product lifecycle itself, I'm going to use problem solving approach. Within the product lifecycle, I'm going to use an iterative approach to come across with the solution. Okay, but technically, whenever you're dealing with this particular books or various other things, you might have come across with these 3 approaches. First one is iterative approach. You might have seen the Morris Simo's model of design process. Okay, where the design process requires inputs, okay, which when carried out through the design process provide outputs. Now this output goes through a feedback process. If yes, go to the next step. If no, okay, again go as a feedback. This is as what is it called, an iterative approach, okay, in terms of a design process. In each and every step of the product life cycle, okay, you carry out the, what is it called, you get the inputs which can be general or sometimes specific to the work requirements. Okay, now this goes through the design process and the outputs are evaluated. If the outputs are, evaluation of the outputs is okay, you go to the next step, or it is sent as a feedback to the next, what is it called, same process, until the evaluation of the outputs is okay for the next step. Next one is problem solving approach. Okay, now most of the times, what is called a design is taken as a situation where a solution is provided for a problem in the market. Now, problem solving approach has got 3 steps. First one, identification of the problem or defining the problem. Second, identifying the root cause. Third, okay, implementation of the solution or defining and implementing the solution. So, in order to identify the problem, we use various techniques like brainstorming and various other tools. Okay, after after defining the particular problem, okay, we use, I will use various techniques in terms of, okay, I'm just revising. If you have any questions, you can immediately chat, because I am intentionally missing some topics here. Okay, these are all available in the material. I'm just touching them. Okay, so that I can complete the whole syllabus. We have very short amount of time here, so I'm just, what is it called, running through. Okay, right. Please don't take doubt questions in between the class. Okay, fine. Fine. Now the next one is identifying the root cause. This particular root cause can be dealt with a situation like root cause analysis. Okay, the ultimate final tool is the root cause analysis and implementation of the solution. First, define the solution. Again, we require brainstorming. After defining the solution, implement the solution in such a way that it is taken as a necessary action, as a corrective action and preventive action, so that this kind of failure or what is it called, a problem does not occur in future. Okay, this is what is the problem solving approach. Now, what is brainstorming? Okay, you can go through the material, or in short, it is a situation where all the various stakeholders or various people who are directly or indirectly involved with the particular problem are put and are confined into a particular region where they propose various ideas towards the solution of the problem, or they propose various causes or various faults that would have led to the failure. All these things are just like they are going to propose whatever comes to their mind, okay, so that they can discuss properly, or it is not going to be discussion. Brainstorming is more like proposal of ideas or causes towards a particular problem or a solution. Okay, now this is what is the problem solving approach. Now the next one is product life cycle. Okay, this topic, product life cycle, is very important because at least one question always touches from this particular product life cycle every year. Okay, it's very huge. At the same time, it covers everything. The first one, product life cycle, starts with the need of the customer or the overall conceptual design stage. So first one is identifying the need of the customer, then gathering the information, analyzing the information, and developing developing concepts, evaluating the concepts, and finally choosing one best concept. Okay, so decision making. All these things come under conceptual design stage. Now, once this particular conceptual design stage is over, okay, it goes to something known as embodiment design. somebody has asked what is embodiment design. Embodiment, by definition, adding a body or a physical form to this particular best chosen concept. Okay, so at the end of the conceptual design stage, you have an idea, okay, of proceeding further. So you are giving it a physical form. That is what is embodiment design stage. Now, during this embodiment design stage, we come across with first defining an architecture for the product. Okay, it can be modular, it can be integral, okay, or it can be a combination of both. Now, after defining the architecture, we go into something known as configuration design. Here we try to give the general shape and size of the particular product. Okay, this particular configuration design deals with the situation where we try to give an overall envelope within which the overall product and all of its components or the architecture lies. All these things are defined in the configuration design. The next one is parametric design. Now, once all this architecture and general shape has been defined, we try to finally freeze the overall design of the product. Okay, the overall size of the product and various other parameters are all freezed. Now, after freezing all this particular shape, size, and dimensions of the product, then we try to identify various variants or parameters and try to tweak them so that we can improve the robustness of the product. Okay, optimize the product, increase the performance of the product, and release various variants. All this are taken care in parametric design. Now, once this particular parametric design is done and we are ready with this particular product, okay, we go through a cycle or phase known as design testing. It comes in embodiment design. This particular design testing happens, okay, at each and every end stage of this particular product life cycle, we go with the design testing. Okay, during conceptual design testing, we test whether the concept actually works or not. So at the particular phase 0, we try to understand the market need. So we provide dummy models of the design to understand how the market feels about or the customers feel about the particular product. Okay, now the next step is the phase 1. Okay, at the end of the conceptual design stage, we use very economic materials like wood, rubber, or thermocol, etc., to build a dummy structure of the particular product. So here, the dummy model is only comprises of external components or external look of the product. Here, we try to build the components and explain the various modules during the conceptual design stage. Okay, this is what is the conceptual design stage. What is it called? Testing happens. So this particular testing at this stage, here we try to get the feedback from the customers. Here we try to get the feedback from the decision makers, if they are interested to proceed with the particular concept or not, or if they are ready to fund the particular concept or not. Now, the next one is phase 2, that is alpha prototype. Okay, where only a portion of the particular entire product is built for giving a direction for the designer. Okay, now here, portion of the product is built using similar materials. Okay, now the next one, very important one, is beta prototype. Okay, where the entire product is built. It can be to the scale 1:1 scale or to the radio scale using the same materials and tested for the product's functionality. Okay, this is the most expensive type of design, and it is going to cost about it is the most expensive type of design, and it provides complete information for the designer, okay, of how the product actually functions at the end of it. What is it called? Actually functions when the user uses the product. Okay, so the overall life cycle, the overall functionality, overall various parameters are tested or information is provided for the designer. So alpha and beta prototype are for designers. Now the next phase is manufacturing stage. Here, or before manufacturing, pre-production stage or pre-manufacturing stage, where here at this stage, certain components are tested whether this particular design is as it is manufactured by the production group. There can be a lot of things that can go completely different from what is being designed to what is being manufactured, because the manufacture generally happens as a batch production, or a huge or mass production, where certain number of components are released in one cycle. So the production level, is it happening as per the design or not? This particular pre-production testing is done. Okay, this is to check the production or construction effectiveness. Okay, so this is what happens in the design testing. Now the next phase is detailed design. Now, once the design is completely over, the designer have to provide various informations or do some last modifications for the design. So to make some decisions in terms of make or buy of the product. Okay, so make or buy of various components of the product. Okay, second, finalize the design testing reports. Then finalize drawings and bill of materials. I hope you guys know what is a bill of material. Then once the finalizing of drawings and bill of materials is done, they are released for manufacture. Okay, now technically, some documentation in terms of what are the lessons learned. This includes a project report or product report. These are some of the things that are actually carried out in the detailed design stage. Now, once this is done, once the detailed design is over, the product is given for manufacturing. So during the manufacturing, they are going to manufacture or plan for manufacture or construction, depending upon the various fields of engineering or type of the product or various other things. So after the manufacturing is done, it goes to the next stage, our customer usage. I'm skipping the marketing stage. Okay, demand and supply or marketing stage here. It is not a marketing class. So the customer uses the product and tries to come up with the fixes that are required with the product or updations that are required for the next version of the product. After a certain period of time, this particular product is no more required in the product, so it is retired from the market. Okay, now this is how an engineering perspective is checked in terms of what is it called, a particular product. Now let us go with the next. This is the overall product life cycle. Now let us go with the next topic of How do I go to the next one? Okay, sorry. Okay, next topic of how the what is it called organization looks at the product life cycle. Okay, this is as the time progresses, and this is the volume of the products or the expenses that the organization has gone across. Not expenses, the volume of the product and the usage of the product that are actually performed. At the initial stages, okay, when it is introduced into the market, it is going to be very low. Slowly it picks up, it reaches to the maximum, and slowly it declines. Okay, this initial stage to this one is the growth stage. This is more like a maturity stage, and this is the decline stage. Okay, and during this point of time, they plan to retire the particular product or review or build a new particular design for the next stage. Okay, so far this is all in terms of the product life cycle. Now, let's go to the next topic. What just happened? Fine. Okay, now once this is done, let us actually understand some of the key tools that are used in the design process. So the product life cycle begins with the conceptual design stage, where we first identify what is the problem in the market. Okay, problem definition and customer needs. So first, whenever the first stage is problem definition for the product. Okay, so whenever a customer proposes various desires, okay, we try to identify the customer requirements. Okay, or customer needs and customer requirements using a Kano's diagram of customer priority. Now this Kano's diagram talks about the expectors. Okay, then the spokens, the unspokens, and the delighters that are required in the particular product. So whenever the customers talk about various requirements of the particular product or needs, the needs and customer requirements, we first try to identify or sort this particular customer requirements and needs into these 4 items: expectors, spokens, unspokens, and delighters. Now, need is something that is mandatory in the particular product, that is defined as a functionality. So that is what is expected. Something that defines the overall product functionality, and what is minimum expected from the product is something known as expected. So these are the features that are expected from the product. Okay. Now, the next one is spokens. These are the set of features that the customer asks or speaks out while defining the particular product. Okay, these are spokens that the customer very clearly defines that these are the minimum requirements that are required for the product to say that this particular product is of good quality. Okay, now unspokens are set of features that the designers add to increase the comfort for the users, where also improvising the overall performance of the product. These are set of features. Okay, so expectors, we can simply say they are basics. Okay, spokens are something that the customer asks for. Unspokens are the comforts, and delighters are the luxury components. More or less, these are some things that the customer does not ask for, but these are some things that drive the customer to purchase the product, or the customer is attracted with these set of delighters. Now, in most of the situations, many of the situations, the customer does not know whether the delighter is completely functional or not. Okay, however, whether they are functional or not, this particular delighter attracts the customer in purchasing the product. Okay, now, in order to make this particular understanding very simple, I'm just going to take an example of a car. Okay, what are the expectors in a car? Okay, you need a steering wheel, you need what is it called tires, you need a seating arrangement, you need brakes, you need a gearbox, etc. All these features are something those are expectors from the car. Now, spokens. Various customers require various spoken requirements, something like that. Some of the cars might contain AC conditioning, okay, or the AC might not be present. Or sometimes it is a power steering or a manual steering, automatic transmission or a manual transmission. All these things are spokens that the customer requests for. Okay, now unspokens. You add some extra features, okay, like what is it called? Decreasing the effort in terms of manual transmission or proper transmission, or provide proper shock absorbing facility. Okay, all these things are unspokens that add comfort or provide extra leg space, okay, or provide extra carrier space, etc. All these things are some things that the customer, though he does not speak of, if you provide, the customer will be extremely happy. And the last one, delighters. If I'm going to talk about the delighters, some things like airbags. Okay, the customer, when he's purchasing a particular car, he does not know whether the airbag is completely functional or not. If at the very end it functions well when it is needed at that particular time, the customer is very delighted because the airbag saved his life. Okay, but if it fails, the customer does not know. Okay, and even the warranty period might have gone. So technically, delighters are something that attracts the customers in terms of purchase of the product, but need not be functional. I'm not saying that these are what is it called? It's not mandatory for the designers. It is mandatory for the designers to be functional, but delighters generally are the things that drive the customer to purchase the product. Okay. Now, after this particular Kano's model, we develop something known as a QFD, a quality function deployment. What is a quality function deployment? See, during the initial stage, when we start our design, okay, or when we plan to design a particular product, we try to understand what is the need of the market. So we gather all the information. Now, once we gather all the information, okay, in terms of the requirements or expectors, in terms of the requirements and needs for the particular product, we sort out this particular requirements, okay, using the Kano's diagram of customer requirements or Kano's diagram of customer priorities. Now, after establishing this customer priorities, we need a proper plan, or we need a proper methodology that is going to guide us, or a route map that is going to guide us through the rest of the product lifecycle. That is properly achieved using quality function deployment. Okay, it is called the word quality function deployment because it is not just confined to one particular stage. Okay, during the conceptual design stage, we are going to build a quality function deployment in terms of customer requirements versus engineering requirements. That means we are going to convert this particular customer requirements into engineering specifications. Okay, a customer can say that I need a particular bike. Now, this particular bike or two-wheeler is going to be of 100cc, 150cc, 200cc are the engineering requirements or specifications. So the customer requirements are converted into engineering specifications in the conceptual design stage. Now, once this particular conceptual design stage is done, during the embodiment design stage, where we give a physical, what is it called, physical form to the particular design. Okay, we take these engineering specifications or requirements and convert them into product specifications. Now you might ask me, sir, what is the difference between this engineering specifications and product specifications? See, whenever I promise the customer that I'm going to provide him a 100cc bike, okay, if you check the diameter, it is not going to be 100cc exactly. It's going to be 99.6cc or 96cc, etc., etc. Okay, the round off figure is entirely different from what is being achieved when I'm actually giving the physical form. That is what is the product specification. This is what is achieved during the embodiment design. Now, once this embodiment design is done, and I'm actually transferring it through the detailed design to the pre-production. Okay, now this particular manufacturing guys are going to look at this product specifications versus what is their process capabilities. Okay, whatever is my product specification during the design, whether it meets the manufacturing capabilities or not, that is what is checked during the pre-production stage of the quality function deployment. Okay, now during the final manufacturing, the process capabilities versus the final product measurements or product what is it called, features, that is what is checked here. This is the actual manufacturing stage. The process capability can talk about giving what is it called, a very good third degree precision or up to third decimal precision. But during manufacturing of the product, there might be some errors or not. So initial stage, we try to check how the customer requirements are converted into engineering specifications or engineering requirements. Here, the engineering requirements are converted into product specifications, where the embodiment design stage is done. And finally, and during the next stage of pre-production, these product specifications are checked against the process capability of the manufacturing guys. And during the final manufacturing of the particular products, okay, the process capability of the manufacturing versus actual product that is coming out are checked. So ultimately, we are converting the customer requirements into the product features. Okay, so ensuring that we are thoroughly carrying out the overall process of whatever are the need of the customer or the voice of the customer through the entire design or what is it called, quality function, or through the entire product life cycle. This particular thing is known as voice of the customer, because it ensures that whatever are the requirements of the customer are carried out throughout the entire product life cycle and guides the designer in terms of maintaining the voice of the customer through the whole product life cycle. This is known as the voice of the customer. Now, this first phase during the conceptual design stage, where we actually convert the customer requirements into the engineering requirements, this first phase of this particular quality function deployment is known as house of quality. This is all about the quality function deployment. So the quality function deployment is a guide map that the designers are going to use as a guiding, what is it called, as a guide map throughout the entire life cycle of the product, so that they can ensure that whatever the customer requirements are, the end product needs the same things throughout the entire process, and they don't deviate from the customer requirements. That is what is this particular quality function deployment ensures. Okay, so far, this is what is quality function deployment. Now, once I establish the quality function deployment, the design team starts generating concepts. This is also known as concept generation stage. Okay, now various things come into picture when you're actually dealing with the concept generation stage. The first thing, one of the first very important thing that is required for the designers is creativity. Okay, creativity most of the times comes only through the art or experience of the particular product. Okay, or the engineers or the designers. It's something intuitive. So technically, in order to understand this particular concept of creativity, okay, we first try to understand the structure of the human brain. This human brain can be divided into two halves: the left and the right. Okay, left is more objective oriented, right is more subjective. Left is decision making, right is creative side of the brain. Left is logic. Okay, this is, you can again say it as what is it called, creative, or you can also say it as flexible. Left is judgmental or decision, judgmental or make decisions in terms of the quick requirements. This is more like flexible, or it listens to the customers. Okay, so based on this particular brain domination theory, okay, or brain structure, this was suggested by some psychologists. If a person is dominated by a left side of the human brain, he's going to be very logical, he's going to be quick in terms of making decisions, he's going to be very objective in nature, he's going to be very calculative, and everything has to happen according to this particular thing. On the contrary, if a person is dominated by the right side of the human brain, he's going to be very creative in nature, he's going to listen, what is it called? He does do not generally like to make decisions very quickly. He's going to be very artistic in nature, he's going to listen to everybody's problems. Okay, whether he solves it or not, he listens to the problems. He tries to be very creative in nature, and always he will not be objective, rather he's going to give a lot of subjective methods, and he's going to be very, or listens, or he's going to be very open-minded. Okay, this is what is the structure of the brain dominance theory, or structure of the left side or the right side of the human brain, and how does it affect the creativity? Or the question can come: so, should the designers be dominated by the left side of the human brain or right side of the human brain? The answer is, at various stages, we need each side of the human brain to be working very effectively. A proper combination of both is required. Now, in terms of this particular left and right side of the brain, if they are properly connected by many number of neural connections, very much, you are capable of doing multitasking very effectively. If the number of neural connections between the left and right side of the human brain are less, okay, then the multitasking is not very effective. The person has to completely, what is it called, focus on either one task. It can be decision making, or it can be only focused on creativity or various other things. Okay. Now the next one is once this has been established, brain dominance theory. There is a structure that was suggested by Sigmund Freud. Okay, and this is also known as. According to Sigmund Freud, who is one of the very well-known psychologists, okay, the human mind is divided into layers. This is known as the onion peel structure. Okay, just like the external layer, then an internal layer, then a very internal layer. Okay, the external layer is the conscious part of the human mind. Okay, and it is the what is called active part of the human mind that consists of 10 to 15% of the human mind. Okay, and it always perceives all the information through various sensory modes. It can be sight, what is it called, smell, taste, or what is it called, voice or touch, etc. All this information that is processed through the various sensory organs is processed through the conscious mind. Okay, and it acts according to it. Now, this particular human mind, you can, I mean, if I'm going to use a computer analogy, this is more like a RAM. Okay, all the information that is processed here is like a RAM. It is stored for a very short period of time. After that, it is again released. So if I need to say it's going to be very few milliseconds to some days. That's it. The information is only stored in the RAM for only this much amount of time. Now, the next one is preconscious. This particular preconscious mind is, I mean, if I'm going to use the same computer analogy, this is like a storage device, like a hard disk drive. Okay. Now it stores all the information for a stipulated period of time. Okay, it can go from what is it called, some days to some years. Okay, so whatever is the information that is stored in the human mind for a stipulated period of time, that is stored in the conscious mind. Now, one more very good news is this particular conscious mind has got complete access of the preconscious mind. That means whatever is the information stored in the preconscious mind, it is completely accessible for the conscious mind. This constitutes of 30 to 40% of the human mind. Whatever is the rest, though the circle is drawn small here, that is the subconscious mind. Okay, now this particular mind, the bad news is humans generally do not have access to the subconscious mind. Okay, so whatever is the information that is stored in the subconscious mind is not accessible. Now, this particular subconscious mind, according to Sigmund Freud, stores all the information right from the birth of the child till the current day or till the death. All the information is very clearly stored in the subconscious mind. Okay, but it is not accessible to the conscious or preconscious mind. But the subconscious mind is responsible for certain habits or behaviors of the people. It can be some kind of phobia, or it can be some kind of attitude, everything. All the learnings which the conscious mind cannot explain is stored in the subconscious mind. Okay, so in short, the subconscious mind is responsible for the behavior of the people. Okay, now let us, you can ask yourself, what is the importance of this particular brain dominance theory or this Sigmund Freud's model of the human mind? It clearly tells you the way of preparation for this particular methodology or for any examination or any situation that you come across. The conscious mind stores the information, whatever you receive, whatever is the information that you receive in any of the situations is stored in the conscious mind only for a simple milliseconds to certain days. Okay, now the next one is, if you want to store this information or click the save button in the computer to store this particular RAM to the hard disk, okay, you need to continuously practice it over and over again, or read a similar kind of material over and over again so that you can put it inside this particular hard disk or the preconscious mind. Okay, subconscious mind anyway stores this information. And one more thing that happens is, whenever you take any information or whenever you come across with situations where the particular scenario is actually attached to an emotion or linked to an event or a day, then it automatically stores from the conscious mind into the preconscious mind. So there are two techniques of storing the particular information from the conscious mind to the preconscious mind. First, practice it over and over again, or second, link this particular information with an emotion or a particular object. Okay, these are certain techniques that are being followed in various methodologies. Now, these are the things that are also related with the creativity aspect of the particular product. Now, whenever a particular designer is actually trying to design a particular product, he comes across with various blocks or barriers to creative thinking. The first two steps talk about how actually the brain functions. This particular thing talks about what are the barriers or some things that stop a person from what is it called, going to the creative thinking. The first one is, you want a break? Okay, this is just another hour of class. I think, yeah, even let's quickly take 10 minutes break and come back within 10 minutes. Okay, let's take a 10 minutes break. Perceptual blocks, physical. temporarily for to creative thinking. Okay, anything blocks or something that stops a particular designer or anyone from thinking creatively. Okay, now this particular barriers to the creative thinking talk about perceptual blocks. Perceptual blocks talk about the inability of the people to actually perceive or understand the problem effectively. These perceptual blocks can be talk about stereotyping. Okay, the next one is information overload. The third one is fixation. Okay, and the fourth one is priming or provision of cues. Okay, let us go one by one. Stereotyping means whenever you come across this word stereotype means old way of thinking. It's the old school way of thinking. Okay, stereotyping means if a person is unable to get across with the latest technologies or latest methodologies, etc., he carries out his own old school methodologies of thinking. That is what is known as stereotyping. In this, when he's trying to hold off to the old methods of thinking, he is not able to see the exact problem from a very fresh perspective. So this is what is stereotyping, and what is it called? Holds the person from thinking about or understanding the problem clearly. The next one is information overload. When a huge amount of information is dumped to you, okay, you don't know where to start. You don't know how to proceed. This is what is a serious problem in terms of information overload. The third one is fixation. Fixation is a situation where, okay, because of your what is it called education or continuous training or various other things, the mind is or what is it called the thinking of a person is unable to proceed further, okay, from a very fresh perspective. Okay, whatever is taught or whatever is learned only through that or whatever is being followed only through those methods only, the person tries to solve the problem. Okay, sometimes many of the problems can be solved quickly and easily from a very fresh perspective if a person starts thinking from a very fresh perspective. Priming or provision of cues. These are the situations that is actually exploited by marketing technology, where the human mind is primed or is actually tamed by providing a huge number of what is it called repetitive activities with which it is tuned in terms of a cue or looks for a cue. The moment the cue is done, the person does not think very creatively or in a very fresh way. He only carries out whatever is taught to him or trained or tamed for him. These are all the perceptual blocks. Now, the next type of barrier to creative thinking is intellectual blocks. Intellectual blocks talk about poor choice of language. Okay, poor choice of language while communicating about the particular problem is an intellectual block. Okay, if the particular person, okay, tries, I mean, technically when I'm speaking of design, if a particular problem needs to be communicated, okay, use some drawing, use a pen and paper to write down what is the process and where the problem actually occurs, rather than saying it verbally. Okay, this is what is a poor choice of language. If you are not using the most effective way to communicate your intent, then that is an intellectual block. Other intellectual blocks can talk about knowledge. Okay, knowledge block or insufficient information. Okay, and again, intellectual blocks also talks about incorrect information. All these leads to barriers in creative thinking. If you don't have proper correct info, then you cannot think intellectually. It stops your creative thinking. Okay, these are intellectual blocks. Now the next one is emotional blocks. Okay, emotional blocks deal with fear of risk taking. Okay, or in short, fear of failure. Okay, now the next one in terms of emotional block is unease or uncomfortable with a chaos environment. The next one is, okay, lack of motivation. These are emotional blocks. The last one is environmental blocks. Now, when I'm talking about environmental blocks, they are the physical environment. Next one is criticism. These are all the blocks to creative thinking. Okay, listen to this again, barriers to creative thinking very clearly, because a question has come from this particular topic. So they can ask from this particular thing, anything that stops or blocks a person from thinking very clearly. Okay, the first one is perceptual blocks. Now, when I'm talking about the perceptual blocks, it is talking about how the perception or understanding of the problem is stopped or bad, what is it called, blocked, okay, in actually perceiving or understanding the problem. Now, this can happen because of old way of thinking, because of the actual, what is it called, provision of information overload. That means dumped with huge amount of information. Now, because of this particular huge amount of information, the person or the designer is unable to see the actual problem because he's completely overwhelmed with the details of the problem rather than the actual problem. Okay, the third one is fixation. Okay, fixation is inability of the person to actually think about a particular problem from a very fresh perspective. Okay, that is what is fixation. Now, the next one is priming or provision of cues. It is a methodology of what is it called, a way in which the mind of the person is tuned, where certain cues are provided or certain methodologies or certain the mind of the person, designer is trained for certain cues, so he does not think again from a very fresh perspective. Now, fixation is because of the educational background. Priming is all about how this particular mind is trained or what is it called, controlled by other guys, okay, or other factors. All these things is priming or provision of cues. The next one is intellectual blocks. This particular thing, intellectual blocks, talk about poor choice of language of communication in design. Okay. Second, insufficient information is an intellectual block. The third one is incorrect info is an intellectual block. Next, coming into emotional blocks. Okay, most of the situations, the designers feel the fear of failure, because of which, that is what is an intellectual, emotional block, and that what is it called, blocks from creative thinking. The next one is unease with chaos. Okay, if there is improper organization of various topics, then the people will not be able to understand or hierarchically represent the particular information. So they feel uncomfortable working in that particular environment or designing in that particular environment. That is what is unease with chaos. Lack of motivation. Until proper motivation is provided continuously for the designer or the person, he does not come up with various things. That is what is lack of motivation. Okay, that means technically there are certain people who are actually self-motivated. Nobody needs to tell them what they have to do. They actually pass for themselves and they get the things done for themselves. Okay, this leaving them, the other guys of the other people are most likely, if you continuously motivate them, only then they perform. If that motivation is stopped or reduced, then the particular person will have this particular problem known as emotional block, because of which he will not proceed further. Okay. Now, the next one is environmental blocks. Physical environment, provision of proper physical environment within which the person does not have any noise, any disturbances, or any other factors while creating certain, what is it called, or while designing a particular product. Okay. Criticism is the most dangerous environmental block for a person. Okay. So whenever a particular designer gives out a new idea, if he is criticized in front of everyone, right there, the people will not open their mouth again properly. Okay. So criticism is a very great hindrance to the design thinking or new ways of thinking. Okay, so these are the barriers to creative thinking. Now, the space was not available, so I just turned off my video. Now let us continue with again. What are the minimum requirement skills for a creative thinker? Okay, or the person who's trying to solve a particular problem. Okay, what are the problem solver skills? Okay, or creative thinking methods. First, most important thing that is required for a person who's trying to solve a problem is sensitivity. Okay, where he can understand that there's a particular problem and it needs to be resolved. So that particular sense, okay, the particular information needs to be gathered, identified, and it has to be cognitively made a decision. That is what is the sensitivity of a design thinker. Okay, the next one is fluency. The ability of communication of the problem or the solution to the various stakeholders has to happen fluently. That is what is the fluency that is expected from the design thinker. The third one is flexibility. The ability of the design thinker or the problem solver to provide various, what is it called, ideas to approach the solution is what is flexibility. Not fixing to one idea, continuously providing various different ideas is what is flexibility. The last one is originality. Ability to provide fresh ideas, original new ideas is what is required in terms of the problem skills for problem solving skills by the creative designers. Okay. Now, these are some things that are expected or certain characteristics that they have to develop over a period of time. Okay, it's not something that is mandatory here. All these skills can be developed over a period of time. Sensitivity, ability to perceive and understand the problem. Okay, detect the problem and cognitively make decisions about the problem is sensitivity. Fluency is ability to communicate about the problem. Flexibility, ability to provide solutions to the problem. Originality, ability to provide new, original, or fresh solutions to the problem. Okay, all these things are problem solving skills that are required by the design thinker. Now, the next one is discussion about when I'm talking about the problem solving. Okay, we have this particular various methods of problem solving. Okay, these are certain tools that are discussed. Okay, first one is brainstorming. Then we have got certain methods known as 5 why technique. Then we have got something known as synectics. Then we have something known as concept mapping, and so on. These are some of the very important things. Okay, first one is brainstorming. As we have previously discussed, it is a methodology where a group of various directly or indirectly people are brought together in terms of the problem or this particular situation, and all are asked to give out their opinions. The opinions can be in terms of ideas to the solution, or the opinions can be a situation where it can be causes for the particular failure. Okay, that is what is brainstorming. They are asked to talk about only single topic that is provided to them. Now, 5 why is a particular methodology where we try to identify what is the root cause of the problem using 5 series of continuous why questions. Okay, that means they start with a why for the particular failure, why it has occurred. Now, this why can give some certain answers. Okay, first. Now, this each and every answer is again asked with a why question. Okay, this is the second why. Okay, is asked with a why question. So the answers again are denoted. Okay, so this becomes the second level of why. Again, the why question proceeds further in terms of asking why. Now, when we are proceeding level by level in terms of the why questions, it can take 3 levels, 4 levels, or 5 levels. Okay, after doing these levels of why questions, we notice that certain number of reasons are continuously repeating. Okay, now if it is very prominent in most of the situations, that is the root cause of the particular failure. So that is where we freeze as it as the root cause of the particular problem. Okay, synectics is an approach where we try to identify an existing solution to the problem and try to apply it or design it to our own particular problem. Okay, it need not be the same exact solution. It can be a completely different solution in another field of engineering or another field of work. Okay, we try to just take that particular solution or approach and try to apply it in our own methodology of thinking. Synectics can be divided into direct analogy. Analogy means trying to identify an existing similar methodology and we are trying to use it in our own particular situation. Okay, direct analogy where we are trying to identify an existing solution and try to implement it in our own particular problem. That is direct analogy. Okay, you can say it as copy-paste engineering, but it is not exactly copy. We are trying to what is it called, take it and make it original in our own pace. Okay, next is fantasy analogy. The designers here try to actually leave the physical world situation, something like friction or gravity or various other parameters that actually happen or present in the physical world. They try to negate those things and try to build up a particular solution. Now, after building that particular solution, they try to add these parameters and get the solution. So initially, while thinking or providing ideas, fantasy analogy talks about how to come up with solutions, whether it considers the physical, what is it called, physical barriers or physical constraints. All these things are taken as negative. So we also allow or encourage a fantasy analogy. Okay, the next one is personal analogy. Personal analogy means where the designer tries to explain the solutions of the problem in analogy with human body parts. Like you can say that a particular what is it called door hinge joint as an elbow joint, something like it moves in a different way. Okay, so whenever he tries to explain the solution using certain body functionality or various other things, that is known as personal analogy. Okay, the last one is symbolic analogy. This is something that is generally used by many of our engineers, and we have thought about it, where we try to use certain set of symbols to communicate our our idea forward. Okay, so these are the different types of analogies or synectics that are used. Now, another kind of extreme or another adaptation of direct analogy is biomimetics, where here in direct analogy we try to identify an existing solution in a different field of engineering and try to implement it in our own problem. Okay, as a solution in our own particular situation. Okay, now this particular thing, the solution need not just come from another solution that is already present. It can also be taken from the mother nature. Okay, some things like if there is a particular a mechanism that is followed by one of the organisms and it is effective in terms of dealing with that particular situation, we try to implement that particular thing in terms of solving a particular problem, like decreasing air friction by understanding the scales of shark while it is swimming quickly through this water. Okay, or usage of various methodologies that are used by various flies or insects in terms of preventing accidents and trying to implement to decrease the accidents on roads. All these things are biomimetics. Okay, the last one is concept mapping. Concept mapping talks about a methodology where chunks of information are provided with respect to the concept at the center of the page. Okay, I'll take this particular concept mapping to the next page, where I have got a particular concept and all the information regarding this particular concept in terms of inputs, outputs, various factors, okay, various constraints. It can be finance, it can be certain catalysts, certain retardants. Okay, all these things, all the information with respect to the idea or concept or the topic are put in the form of a structure where the person can easily read it and understand it. This is a pictorial form of representation. One advantage, what they say about concept mapping is the human brain also stores the information in this methodology of concept mapping. So storing this information in the method of a concept map helps to quickly read and retain the information for a long period of time. These are the four methods. Okay, these are the methods where the the idea or the concept that is generated by the team is communicated. First, gathering the information about the idea and communication of the information to the various teams is done using these methods that we have just discussed. Okay, brainstorming, 5 analysis, synectics, or concept mapping. Next one, once we have developed a particular idea, we go into the depths of the idea using certain creative methods in design. Okay, now the first one is during the generation of the design concept. The first step is, the first systematic step is function decomposition. An existing function is broken into subfunctions, okay, and the flow between these functions is identified. This is what is function decomposition. The second one is morphological analysis. Okay, function decomposition is carried out in conjunction with morphological analysis. So at the end of the function decomposition, let us say that there is a primary function. Okay, now this particular primary function requires two secondary functions. So technically, function decomposition talks about the addition of these secondary functions to achieve the overall primary function. Okay, now this particular secondary functions, all I'm going to do is for each and every secondary function, I'm going to develop all the available concepts or ideas that can give or achieve this particular secondary functions. Okay. Now, out of these ideas that are generated, I try to choose the best idea. Okay, and build a hybrid design. Okay, for this particular functions. Okay, so that is what is known as a morphological analysis. It's a hybrid design by choosing the best idea concepts of each subfunction. That is what is morphological analysis. Okay. Now, the next, once we are done with this morphological analysis, okay, we have developed a particular concept. We know what are the primary functions of the particular concept. We know what are the secondary functions, and we have developed various ideas for that particular secondary or tertiary functions, and we have developed what is the hybrid overall functionality of the particular product or the concept or idea. Now, like this, certain ideas are taken, and a decision has to be made of choosing the best idea. So this is what is decision making or concept selection. So just understand that what are the various methodologies of making decisions. Don't try to actually learn this particular methods. Okay. Okay, very good. Before going into this, one good question asked by one of our friends. Solution neutral. Suppose, let me take a simple example of what is it called, solar water heater. Okay, now this particular solar water heater requires a solar panel as function one. Okay, water storage. Then I also need battery. These are my subfunctions. I need solar energy to be captured. I need water to be stored and heated, and I need this particular electricity to be stored here. These are my subfunctions. So what am I doing here in functional decomposition is I'm trying to identify what are the subfunctions here. Now, how I am achieving these subfunctions? Okay, what is the size of the solar panel? How am I going to mount it? How am I going to achieve or capture the solar energy? All these questions are not answered in terms of this function. Okay, water storage. What kind of water storage am I going to use? Is it a syntax tank or a cement tank, etc., etc.? How am I going to heat the particular water? All this information is not provided. I'm just saying that I need water storage. Battery. What is the capacity of the battery? Okay, how am I going to store it? Where am I going to store it? How am I going to connect it? I'm not providing any information about that. All I'm talking about is the subfunctions required to achieve the main function. Okay, how we are going to achieve or how we are going to build the subfunctions. I'm not going to talk anything about that. This particular methodology is known as solution neutral. I'm not talking anything about achieving the subfunctions. I'm only talking about the various breaking of the functions in the least subfunctional component so that I can achieve the main function or I can see the main function to happening. This particular thing is known as solution neutral. Am I clear so far? Okay, so this is what is solution neutral means. Sorry, we were going through the decision making, right? Okay, remember one thing in terms of decision making. Okay, During this decision making, we are choosing the best concept. Okay, now this best concept can be done using pulse matrix. Second, decision matrix, analytical hierarchy process. Don't go much into the details of this. Okay, just understand this, that pulse matrix, decision matrix, and analytical hierarchy process, when followed, you get the best concept to be proceeding further. Okay, now so far in the 4 or 5 years of this IES design engineering, they have never touched this particular decision making topic. Okay, again, in terms of decision making, this is going to be very complex in terms of discussing this particular individual methodology. It's not easy and it's a very subjective answer. So definitely they are just going to touch the names of this particular pulse matrix, decision matrix, and analytical hierarchy process. Just understand that. Okay, pulse matrix, okay, starts comparing the ideas against some reference or benchmark value. Okay, so here we are comparing these ideas against reference or benchmark values. Okay, so this is what is pulse matrix. So if they are very good in terms of this against the benchmark values, we give a positive score, and the score is overall calculated to choose the best concept. Now, decision matrix is overall feedback or rating given to each and every function by the various stakeholders who are directly or indirectly involved in the product life cycle. So this overall rating is what is going to define the overall choosing the best concept. Analytical hierarchy process is a huge process, and it involves again as an overall rating. Okay, in terms of choosing the best concept. So decision making process in a single shot can be treated as a situation where we are choosing the best concept using various methods. Okay, where we are comparing the concepts against one another with respect to a reference value or benchmark value. Okay, decision matrix talks about comparing the concepts against one another by using an overall rating methodology. Okay, again the same thing works out with analytical hierarchy process, where the concepts are compared with respect to each other using a particular methodology. What is it called? Using an overall rating. Okay, this is what is decision making. Now, once this particular decision making is done and we are done with the best concept or choosing the best concept, we go across with the embodiment design. Already I have discussed what is an embodiment design. Embodiment design is adding a physical form. Okay, so when you're adding a physical form, you first build an architecture. Architecture is the arrangement of the physical components to achieve the desired function. Then, once we build up the architecture of the particular product, we go with the configuration design. Then we go across with parametric design. Then we do the design testing. Then we try to implement DFX, design for X. Okay, so architecture again we can break it into modular and integral. Modular architecture talks about breaking the functions, okay, or dividing the components based on the different functions. Integral architecture talks about combining various components together to achieve the overall product function. Modular architecture increases the weight of the product and increases the number of components of the product. Integral architecture combines the product so the number of components are decreased, so it reduces the overall weight. Sorry. Now, when discussing about this particular modular architecture and integral architecture, just always keep in mind that modular architecture is less efficient when compared to integral architecture. Reason is, in modular architecture, because there are maximum number of components, the interfaces between the components are also increased. Sorry. Because the interfaces between the components are also increased, there is an efficiency drop because of the increase of number of interfaces. So now this particular drop of efficiency can lead to less efficiency in terms of modular architecture, and because the number of interfaces are less in integral architecture, it is more efficient. Now, because the number of components are very simple and easy to copy, modular architecture can be easily copied by a competitor. Integral architecture cannot be easily copied by a competitor because the components are a little bit complex. Okay, when you're adding 2 or more components or functions together, the component or the product becomes slightly complex. Okay, so it cannot be easily copied. Now, here in configuration design, we try to establish a general shape and size of the product. Okay, now this particular when you're establishing the general shape and size of the product, okay, we try to deal with various situations. So all this particular components architecture are tried to be built in terms of a particular configuration or a general shape. This particular thing is known as configuration design. Now, when we are actually dealing with this particular configuration design, we take into situations or considerations something known as the form of the particular product or shape and size of the particular product. We also talk about the function that this particular product has to achieve. The material that this particular product has to use, and last but not the least, the manufacturing process that this particular product has to, what is it called, the manufacturing process that has to be used in terms of developing this particular product. And again, the function and material talk to each other, the function and manufacturing process talk to each other, the material and manufacturing process talk to each other. So technically, this particular thing of form, function, material, and manufacturing process all talk to each other. Using all these parameters, we try to build a particular configuration design where we achieve the general shape and size of the particular product. Okay, this particular form also talks about the various constraints of the overall shape and size of the product. Okay, what is it called, the interfaces between the various components. Okay, and how many components are required. How many and what is the overall shape and size. This is what is the overall idea about the configuration design. Okay. No need to just, you don't have to exactly remember this. Just understand that whenever you're giving a general shape and size of the particular product, okay, what are the factors that come into picture? Okay, you have to think about the general shape and size, that is the form. You have to think about the overall function of the product that the product has to achieve. Okay, in order to achieve the form and function, you need to deal with the manufacturing process and material. This is what is overall the concept of configuration design. Now, the next one is parametric design. Just one more topic, one more small thing that I forgot in configuration design is during this configuration design, we also try to identify standard components and assemblies and special purpose components and assemblies. Standard components and assemblies are the things that are readily available in the market so that we can purchase them from the specified or standard vendor or potential vendor. Okay, these things can be bearings, motors, or various other components that can be easily purchased and assembled. Special purpose components are something that have to be inherently manufactured individually by the organization for the specific product. Okay, we try to identify the standard components and special purpose components during this configuration design. Okay, now the next step in terms of the embodiment design is going to be parametric design. Here, in terms of parametric design, we try to identify various parameters. Okay, parameters can include dimensions, can include materials, Okay, and various other things that can be changed. And whenever we change this particular parameter, we are trying to achieve a better performance. Okay, not just better performance, we can even achieve better features. All these things are controlled using the parameters. Now, this particular parameters, or when we actually tweak this particular parameters and we try to deal with this, we try to also use this particular better performance, robustness, and actually increase the overall efficiency of the product. This is what is done during the parametric design. Okay. Design testing I have already discussed during the product life cycle. So I'm just going to discuss something is the FX. Design, or in short, it is design for X, where X is a measure of a process capability. Or you can simply say it is a measure of performance of the particular product. If this performance can be safety, this performance can be what is it called, testing, etc. Okay, this DFX can be this X. I'm changing it to MA, design for manufacture and assembly, ensuring that this particular product has got or is made in such a way that it helps in ease of manufacture and assembling of the components. This is what is DFMA. Second, whenever we are designing a particular product, we have to ensure it easy for testing. Okay, we have to ensure it that it is safe. Okay, design for safety. Always keep one thing in mind whenever I'm talking about design, or sorry, whenever we're talking about design. If your safety factor or if your safety always talks about safety of the people, safety of the property, and safety of the environment, then your definition of safety is complete. It should always include all the three parameters: people, property, and environment in all the dimensions. Then your safety definition is complete. Like this particular definition or DFX list goes on. These are some of the important things. Okay, that are generally asked for. DFX, DFMA, DFT, DFS. Okay, this is what are generally asked for. Now, with this, I'm going to complete my design discussion also. So if you have any questions, please type them quickly so that we can go across or quickly revert back to various questions. Okay, excellent. First one is, what is biomimetics? Generally, whenever a designer tries to create a new product design, okay, he tries to take it as an analogy or a learnings from various existing solutions. This particular analogy methodology is known as synectics. Now, this particular synectics has got something known as biomimetics. Biomimetics means mimicking an existing biological method solution that has been adapted by an organism. Okay, and we try to mimic that particular methodology or use the same methodology for our solution. That is known as biomimicking. Okay, so in short, if I have to talk in terms of biomimetics, okay, so previously when they were actually designing these aeroplanes, there was a huge drag or there is a huge air friction that was coming onto this particular surfaces of aeroplanes. So because of which the aeroplanes could not travel faster. So they started studying some of the animals in the sea, something like a shark, where the external structure or the external skin of the shark has got certain different scales with which they were able to decrease, or the shark is able to decrease the drag that is caused by water. Okay, now similar scales are actually implemented on the aeroplanes so that the drag of air is also reduced or air friction is also reduced. This particular methodology is known as biomimicking. Okay, so we try to adapt from the mother nature. Or you might have learned that what is it called, the inspiration that the Wright brothers got, okay, in terms of flying was from the birds. Even that is known as biomimicking, where we try to get or capture the idea from an existing solution or an existing methodology that is that has been provided by the mother nature. That is known as biomimicking. Next question. Okay. Now, so far you have listened to all the class. Now here are some very important tips that you have to remember for the examination. Okay, this design, okay, and safety are two different core engineerings in the higher studies. Okay, in masters or it can be in what is it called, PhDs. There are a lot of things that are going to go on. Okay, now this particular topic is taken in a general study subject. It's not taken in a core study subject. It is taken in a general study subject. So what you are expected to remember, okay, in terms of all these topics is a very simple logic of how to achieve the overall product. Okay, it can be mechanical, it can be civil, it can be electrical or electronics. Okay, no matter what kind of product you're designing. Okay, whenever you're designing a particular product, when you're trying to bring it into reality or into the market, you have to think that this particular product should be successfully, what is it called, meeting the need of the customers. Okay, so by definition of this particular general principles of design, you should know something like the product life cycle and some things that affect this particular product life cycles. You're not asked more than that. Okay, so even if you feel at any point of time during your preparation, okay, then what is it called, the information is overwhelming, I'm going to just tell you a simple technique. The material for design and safety is not very much in the material or the ACE material. Okay, that was intentionally put that way. Reason is, if we continuously add the number of pages, it is going to lead to something known as information overload. Okay, that is not required in design and safety. Okay, you just have to make the decisions based on an understanding of what is required at this particular scenario. No need of taking all the information. Just understand the question in a very general sense and answer the question. This particular design topic or safety topic, I'm saying very clearly, bluntly, that if you have gone through the material completely, okay, and if you have understood this particular thing, I'm not talking about memorizing, I'm talking about understanding this particular concepts. Design and safety questions, which are somewhere around 4 to 8, that depends upon this particular year, every year. Okay, design, they're definitely going to ask 4 questions. Safety, they're definitely going to touch 4 questions. So overall, 8 questions are mandatorily bare minimum expected from design and safety. And these 8 questions, you will at least answer 6 to 7 without any difficulty if you put your presence of mind and think fully based on knowledge provided in the material. You don't require any extra thing. And the last one question is always a trap. Okay, it is always, I mean, every year it is observed that they try to delay or waste some time of the student while conducting this examination by giving one question that wastes or that spends more time to solve. I'm not saying that this is just going to be a tough question. I'm not saying that you don't have to answer the question. Just engineer or designer by definition is considered to be the smartest person. So be smart. Whenever you identify that a particular question is going to consume more time, or whenever you try to identify that this particular question, you know the answer, but you're unable to immediately remember it, just mark the question and come back to it. Okay, leave the question for the conscious mind to fetch it from the pre-conscious mind. Okay, and keep it ready for you. Okay, you don't have to struggle or break your head at that point of time or waste your time for that particular question. Okay, this justification I can give very comfortably for design and safety because the questions are going to be very simple if you are able to put your presence of mind. Don't try too much or too hard in terms of memorizing all these concepts or other things in this particular topic. It's easy. You can easily get through in terms of this particular general studies if you keep your presence of mind. That is a very easy and simple suggestion for your IES. Every year it is observed that, okay, if you read a lot of answers for the design and safety, you will answer less questions. Rather, if you are able to understand them and able to apply them comfortably, that is sufficient enough in order to score good marks in terms of design and safety. Okay, this being a general study subject, take it very generally. Okay, I'm not saying that take it very casually, don't read the material. Just read the material once, understand what is being told there, that is sufficient for you. Okay, any more questions? Okay, I see some questions here. Okay, he's talking about adding the vortices or adding a flaps that was observed from eagles. I'm not talking about flaps. I'm talking about the scales on the skin. Okay, if you observe this particular structure of this particular airplanes, okay, in the recent fighter aircrafts, they're adding an extra layer of skin that reduces the drag of fighter aircrafts. You can refer it if you want. Okay. Yeah. Somebody asked the classes of fires. Just one quick revision about the various fire or classes of fire. Okay. Now, if you go to the material, you observe that there are different classes of fire. Okay. Just remember it as A, B, C, D, E, and K. A stands for solid forms of fuels. The emphasis is given on the type of fuel or the state of the fuel. Okay. Solid fuels. B, liquid. C, gases. Okay. D means detonating substances, something like liquid metals. E is electrical equipment. K means substances that are present in kitchen. It can be oils. Okay. Not just oils. You can even match them with grease. Okay. Oil or grease. These are the fuels that are going to burn in any, found in any industry. Okay. Now, technically, whenever you're dealing with, or whenever you're imagine a situation that you have noticed a particular fire in a structure or a building, and you're calling the fire station. Okay, they're not just going to run to the particular situation considering this. They're going to ask the person who has reported with the rapid fire of questions. What is the location of that particular region? Second, what is the industry or what is the burning substance? Third, how are the fires spreading? Fourth, is there a nearby locality? Like this, they're going to keep a rapid fire of questions in order to prepare for the fire extinguisher during the day. Okay, now if it is a solid fuel, water is the best way of controlling it. Okay, for the rest of all, water does not work. Okay, now the next type of fire extinguisher that we generally use is carbon dioxide. Okay, now the carbon dioxide is not used for solids. It can be used for liquids if they're not flowing. It cannot be very much used for gases. Okay, it is not effective in terms of liquid metals, but it is very much effective in terms of electrical equipment. Oils and grease, again, it is not effective. Okay, so technically, this carbon dioxide, you can understand that carbon dioxide cannot be used for gases because the gases escape and continue to continue to burn. So gases is not carbon dioxide is not effective in terms of gases. Okay, or liquid metals of oils and grease. But you might have a question, sir, why carbon dioxide is not effective in terms of solids? Here, if you read the science of fire, you notice a particular word known as smoldering, or another word that is used is smothering, where there is a particular situation in specific to the solid fuels where because of lack of supply of oxygen, the particular substance will be having all the energy to burn continuously, but because of lack of supply of oxygen, it tries to stay in a smoldering state. Okay, now if you're actually trying to extinguish a solid state fuel that is actually burning, it can be coal, wood, or it can be paper, etc. If those are burning and if you're using carbon dioxide, you are temporarily cutting the supply of oxygen or oxidizer. Now when you're temporarily cutting the supply of oxygen, the fuel undergoes a process known as smoldering or smothering. Okay, now the very next second you are going to turn off, or turn off the carbon dioxide, again the fire continues to burn. That is why it's not effective in terms of putting it off in terms of this particular or using in terms of solid fuels. The next one is dry powder. Okay, dry powder, it can be very much effective in terms of solid fuels. Okay, in terms of liquid fuels, it actually this particular dry powder comes in as acts as a sealant in case of in case of leakages of liquid fuels. So it is very much effective in terms of liquids and gases because it's not going to principally cut off anything. It is going to act as a seal wherever there is a particular supply of gas or liquid, and thereby cutting off the supply of this particular supply of oxygen or supply of fuel for that particular situation. Thereby, it is very much effective for solids, liquids, and gases. Okay, for liquid metals, imagine this particular dry powder. Okay, it's actually an ammonia salt, which is very inert in nature. So technically, this particular thing has no reaction with those liquid metals. So it is very much comfortable to control the fire that is caused by liquid metals. Also, because this particular dry powder is a bad conductor of electricity, it can also be used for electrical equipment. The only problem with dry powder is after extinguishing the fire, the paste turns into a huge dust trap that the humans where people cannot go very quickly. Okay, or it is going to leave a huge amount of residue after this. So generally for electrical equipment we use carbon dioxide because it does not leave any residue. But dry powder leaves a lot of residue, so we generally don't consider dry powder for electrical equipment. Oils and gases, it is still not considered. Okay, so these are the three major fire extinguishers that are generally used. There are other ones where you can use some dry chemicals or wet chemicals, which are generally very effective in terms of solid fuels and in terms of controlling this oils and grease. Because these wet chemicals have got a particular soapy substances, or whenever they are actually put onto this particular situation, they form a soapy type of situation or soapy substances where they immediately absorb or react with oil, thereby causing this particular or deteriorating this particular burning methodology or burning scenario of the oil, thereby putting off the fire. They're very much effective for grease or oils and only for solid fuels. The rest of the fuels, because they're chemical in nature, they generally cause more harm than actually benefit. Okay, these are the various classes of fire and these are various fire extinguishers that are generally used. Okay, any questions? Now, technically, one of our friend has asked out of the scope of this particular subject. See, whenever I'm talking about the fire safety, first you have to understand this particular fire safety, whatever we are dealing here in the subject, is only constrained to industries or structures. It is not taken. I mean, this particular topic is not taking consideration of open fires. It can be forest fire. I'm not talking anything about the forest fire, or I'm not talking about the fire that are happening in terms of oil or gas plants, or what is it called a CE situation. But in terms of the answer that here, what you're asking is, if there is a fire like in a petroleum station, with what is it called? If there is a fire in Mexico Gulf or a gas pipeline that burns within the sea, there's a huge spill of oil around, and the fire continues. Okay, so which type of fire extinguisher is supposed to be used? Technically, the answer here is most of the situations they try to use some kind of liquid chemicals or wet chemicals where they try to dissolve the oil, okay, and deteriorate the burning substances of the oil. They cannot use water, they cannot use dry powder, they cannot use carbon dioxide. Only way is continuously provide wet chemicals so that this particular oil is dissolved. Okay, now once this particular oil is dissolved in this wet chemicals, it decreases this particular category of what is it called, the burning nature. Also, there is a that is the most effective answer, or that is the most effective way that they are using, because they are pouring a huge amount of detergents into the sea. Okay, though there's a huge amount of aquatic life loss because of that particular spill or detergents. I mean, you might have seen many documentaries where they continuously blame the people, saying that if there is an oil spill, okay, then the amount of detergents cause more harm than the oil spill, because the detergents immediately kill the aquatic life in that particular region. Okay, but the only solution that the humans have got so far is providing or continuously using wet chemicals or detergents to dissolve the oil. That is the solution that is used here. So about design, to what extent we need to cover. Understand the concepts of product life cycle. Okay, understand what is happening in the product right from the need that is identified in the market to the solution that is provided to the customer, and what are the steps taken. Okay, the rest of the things that they are going to provide, or the questions that they're going to ask, are going to be straightforward, easy. Okay, and if they want to literally make it tough, they're going to ask an application. And the moment you feel that particular question is tough, please mark it and proceed further. Okay, there is no specific limited amount, what is it called, constraint in terms of syllabus, in terms of general design and safety, because the more we go into depth, the more the syllabus is covered. But because this is general studies, just keep it general. Okay, you can easily score more than what is called 4, or sorry, you can out of 8 questions, you can easily score more than 6. Just be confident and keep your cool when you're answering this particular questions of design and safety. Okay, the question itself, most of the times, what we have observed is most of the times the answer is present within the question or the options. Just logically evaluate the questions. Exam will be online or offline. Please check with UPSC. Okay, most of the times I think it is going to be offline, because there are 2 sessions of the examination that are going to happen. I think it is going to be offline. Okay, any more questions? No questions. So shall I end the session? I wish you all the best. Okay, prepare with cool intellect, no matter which stream of engineering you are from. Okay, be cautious, be present with all your mind. Okay, and be smart in terms of choosing the answers. Okay, whether you are from mechanical, civil, electrical, or electronics. Okay, all the questions are directly related with your approach only. Okay, so all the best. Okay, and come with flying colors. That's it. I'll call it done here. Thank you so much for your time. Wish you all the very best.